and welcome to Unapologetically Technical. This is a show that's different. We go all the way down. In this case, this will probably be one of the most technical shows we've done, and we're not apologizing for it because this is why you're watching, hopefully. With me today is Gunnar Morling. He is the creator of the 1
Hey there.
billion row competition and a senior staff engineer at Decodable. Welcome, Gunnar. Would you mind introducing yourself a little bit more?
Hey there. Yes, Jesse, thank you so much for having me. Really great to be on your show. Yeah, I work as a software engineer at Decodable, where we build a real-time ETL, a real-time data movement platform, and we can talk about what that means. Before that, I have been for many years with RedHat, where amongst other things worked on Debezium, which is a platform for change data capture. So I guess we'll talk a little bit about that. Yeah, and I live in Hamburg in Germany, and I'm very happy to be here with you today. And let's talk about all kinds of technical stuff.
Well, let's also well, we can't not talk about Legos either, so we'll have to do that as well. So,
oh yeah, absolutely, definitely.
Yeah, if people haven't noticed, there's lots of Legos behind you.
Right. Yeah.
Other side.
Yeah.
There you go.
Yeah.
So let's start with this question. You've talked about the places that you worked, and one thing I found interesting, not just about you, but I would say Germans in general, is that the fewer number of places that you work at. In your case, you've only worked at 3 places in your career. What perspective or advantage does that give you?
That's an interesting one. It's an interesting observation. So, I mean, to be fully transparent, I've been at some other places before. So overall, I don't know, like 5 or so. But yeah, not a large number, not a huge number. And yes, I think you're right. I guess there's some sort of stigma if you were to change like jobs too often. So I know if you were to move to a different job like every year or so, I think people would find it a bit weird, at least in how I perceive it. I'm not sure whether that's exclusive to Germany or not. But yeah, so certainly that's a thing. But also, yes, so those previous jobs, and it was like in a retail industry, it was in logistics industry, always in IT and software engineering. I don't really refer to them an awful lot just because I think probably people don't know those companies, in other countries in Germany. And also, then for a very long time, actually for 10 years, I've been at RedHat. So all this has been like very long time ago. But I think in general, I feel, yes, staying at a job for several years, I mean, that's what I would aspire for, right? Because it actually gives you the opportunity to experience what you have built, right? So you create something, you move it into production, and then you don't leave, you don't move on, but you also are part of like operating this, and you probably get to pay for any mistakes which you made or any like poor design decisions. And I think that's very worthwhile. So that's why I would always strive to stay at one place for a couple of years, I guess.
You brought up something very interesting, and it's something I've talked with other people about, and that is if you move every year, let's say year and a half, you've never experienced the problems of your decisions before. You've always
Right.
moved on, and so there's never not this reinforcement cycle of I made this mistake or I made this thing right,
Exactly.
and you go around. Talk more about that and why that's important.
Oh yes. Well, I mean, you need to have this hands-on experience, right? So let's say for Debezium, I was working on that for 5 years, give or take. So I would say that's a reasonable long time where we realized, okay, those things which we did maybe at the beginning, they were not the best thing we could have done because I don't know, just created too much effort. It was just too complicated to maintain things later on. So in this project, we had those different CDC, change data capture connectors for a variety of databases. And initially, for instance, there was a little bit of framework around it, I would say, but also there was lots of repetition redundancy across connectors. And then as we were to add more connectors, like the 4th and 5th connector for other databases, then we realized, well, we actually got to pay for that, right? Because we kind of have done a similar thing before. So what we then did after a while as well, we extracted a framework, which then allowed us to build new connectors based on top of that more easily, right? And I think you probably wouldn't have done this like if you just had done it like once and then you would have moved on. So I think that's the kind of experience where you need some time to also then to see, of course, what are the right abstractions, right? I mean, you also don't want to start with some sort of framework right from the get-go, because then you don't really know what are like the different aspects which need customization and so on. So all those things, I would say, just take some time and you've got to go through it.
I would agree with you. I gave a talk recently at Day-to-Day Texas where I talked about this as well. And one of the trends I'm seeing in our industry, which is I think going to be terrible for our industry, frankly, is that we have people who are guiding or being seen as influencers who've had only a year at each place. And the issue with having only a year of experience at each place is you didn't really gain experience. You gained a title change, but you didn't really gain experience.
Right.
So you have essentially, in my opinion, beginners. You have beginners who've done the same thing over and over, but have never had the time at that place to say, oh, that's the wrong thing, that's the right thing. I think it's going to be a pretty bad situation.
Yeah, no, I mean, definitely. And also, I mean, as you say, influencers, that's an interesting point. So what I observed maybe during the pandemic or maybe low interest years, low interest, uh, uh, this time of period where money was just very cheap, that you actually would have also within like DevRel and outreach, you would have people which are like very new to the industry, right? Maybe they did their first job as a developer advocate, and I know in particular in this role where you want to talk to people based on your first-hand experience, probably it's not ideal to start off with this kind of job as the first thing, and maybe it makes more sense if you move into that after some time.
It is important. Continuing down that line of gaining this experience, what is something that you think a person who's only had that experience, that long-term experience, could do or see?
I mean, wow, that's there's a few things to that, right? I mean, I would say first of all, there's this entire notion of observability, right, and running stuff in production, and even more so in a place where I'm at right now, where we actually build a software as a service, so which means we get to run this ourselves. But then also similarly in the library or framework space where I was before, where other people run it. But building out means of understanding what a software system is doing. I think this is something, well, there you just need to have some sort of experience and like long-term time for going through this, because I know it will take some time until people run into some sort of weird corner case, some weird edge case, right? And you want to make sure that you can diagnose this properly. So I think that's one thing. And now again, as I work on a SaaS myself, it's even more imminent, right? Because I mean, we are operating this thing, and then we want to make sure that we stay on top of things and we know when there's like failures for our users. And just understanding what kinds of failure scenarios there are, I think that definitely takes some time. The other thing I would say is, as I mentioned before, like finding the right abstractions. So I don't know, being at one place for some period of time sometimes gives you the opportunity to build something a second time. So let's say in Debezium, like we added another connector. And before in Hibernate, I was working on this validation framework, and then it was extracted into a spec under the Java community process, the JCP. So you get this opportunity to do something again, which you have done before, and then you have, of course, a much better intuition about how should this look like, what are maybe the non-obvious design considerations, maybe performance considerations, all those kinds of things. So I feel that's another thing. If you do it for the first time, well, you do it for the first time, right? So you don't have those experiences. And I think to do it a second time, you probably need to stay some time around to get to experience that.
I would agree with you there. I've made this suggestion to various companies as they start out, let's say a product or something. You ideally want somebody who's doing it the second or third time, not the first time.
Right.
Not that you did bad in the very first version, but you'll make mistakes, and that you're going to make some trade-offs and hopefully some fixes in that second version, and you'll get that hindsight. And I guess it's part of why you see that version 2 of whatever, even of hardware designs, they experienced the same thing. They just didn't
Right.
know what to do that first time.
Yeah, and then of course there's also the risk that you want to overdo it the second time, right? So maybe that's something you might actually get wrong if you're earlier in your career. I don't know. So you get this opportunity to do something a second time, and then you think, oh, now I want to get it right completely, and I build something super complex to I don't know, take into account all kinds of possibilities. And then maybe it's actually too complex. I mean, I guess that could also happen if you get into this situation for the first time to do something the second time, if that makes any sense.
Yeah, I also, for example, HTTP, I think is a great example of that. The HTTP protocol, where the very first version, if people don't know, it's all text. There is no binary going back and forth for HTTP 1. And I think that if they had done an HTTP 3 or HTTP 2 style, where it's binary, it might not have went as well. That there had to be that progression. Do you agree
Right.
there?
Yeah, definitely. I think so, yeah.
Okay, let's talk about Red Hat now. And what was you were there for 10 years, so it's going to be hard
Right.
to distill 10 years of experience down. But
Right.
what were you doing at Red Hat?
Yes. What was I doing there? So I would say largely I could, divide this part of my career into two parts. And the first one was, and I briefly hinted at it, I was part of the Hibernate team. And actually, the way I came into that team was I was contributing to open source projects from the Hibernate umbrella in my spare time before then. So one of those other jobs before Red Hat. I spent the evenings and weekends and doing some stuff in the Hibernate ecosystem. And yeah, at some point they had an opening and they asked me, so, hey, would you be interested in joining? And I thought, sure, let's give this a try. And so this is how I came to join in 2012. And then, roughly speaking, for the first 5 years, yes, I was part of the Hibernate team, and most people probably know it for Hibernate ORM, the object relational mapping tool. People love it or hate it. I think it's often misunderstood, but it is what it is. And I was not working that much on Hibernate ORM. I was more working on other things which are adjacent to it. So most importantly, I was working on what we called Hibernate Validator. So that's a declarative engine for enforcing invariants to your object model. So it's annotation based, which means you put annotations like @not_null or @min, @max, or maybe @regex or something like that. You put those annotations to your object model, and then the engine will validate them at suitable points in the object lifecycle. So, for instance, if you put those annotations to a model which backs some sort of UI dialog, well, and then those constraints would be validated when the user submits this form. Or if you were to put those annotations to your persistent object model, then JPA, the Java Persistence API, would validate those constraints when you are about to commit your transaction. So those kinds of things. So I was working on that a lot. And this was a project which was part of the Hibernate project family. And then also there was actually a specification which evolved out of it. So this is the Bean validation spec. It was developed back then under the Java community process, the JCP. And I think one of my personal highlights during those years was when I got to be the spec lead for the Bean validation 2.0 spec. So I was working, I should say for the 1.1, I was part of the expert group. Emmanuel Bernard, another Red Hatter, was back then the spec lead. And then for 2.0, I took over as the spec lead. And this was a great experience to work with people from different companies, because that's always what the JCP was about, to bring people together from different companies, private people, to work on those standards based as much as possible on practical experiences, based on prior art from projects like Hibernate or Hibernate Validator, I should say. So yeah, I was working on that spec for, I don't know, maybe a year or so, something like that. There was another project which is really forgotten by now. It's called Hibernate OGM. This stands for Hibernate Object Grid Mapping. So essentially, the idea was to take this object relational mapping engine and apply it to other things than relational databases. So this, you could use it to talk to MongoDB or Cassandra, Neo4j, and a few other databases which I don't really remember. I was working on that a little bit. It didn't really gain much traction. I also feel there were some flaws. I hope people won't hate me if I say it, but I feel there were some flaws with the general idea around that of taking this stateful engine and applying it to, I don't know, frameworks or databases which, mostly don't even support transactions. But yeah, so that was another thing which I did during those Hibernate years. And then in 2017, I wanted to do something else. I was still very happy at Red Hat, and the opportunity came up to take over the lead for Debezium, and this is what I then did in 2017.
That's quite a bit. So there's a few things that I saw or I heard in there that were interesting.
Right.
When I often describe the people who create frameworks are different from the people who use frameworks.
Right.
And you ideally want somebody who's put their foot in both sides. It sounds like you've put your foot in both sides. And I think there's a problem, I would say not just in data, but I think in the industry in general, where somebody's first job out of college is to create the framework, but
Right.
they've never actually worked on that end.
Right.
What do you think happens there?
Yeah, no, definitely. I would say that's an anti-pattern. Definitely, I think you should, first of all, have been on the user side. And I think all the people which are part of the Hibernate team, and I think other teams at Red Hat, I would say, they all came into that by using it first. I mean, this was pretty much the classical hiring approach. So somebody might, like me, who used this stuff in their everyday job. So we were using bean validation. Then just picked my interest, and maybe I found a bug, or I felt there should be like a specific feature which wasn't supported yet. So then I started to contribute to that project. And at that time, yes, so you're both, right? You're a user and you're also an author of that library, which, as you say, is like really a sweet spot. But yes, also then if you work on that full time, yes, that practical hands-on experience, it can happen. You lose it, right? Or it's just not as prominent anymore. I mean, sure, people working on Hibernate ORM, they don't really use it every day, so they know all the ins and outs about it. But then it still might be surprising. So I always found it surprising how people are actually going to use those things which you build out or which you put out there for them. And I think what's super important there is to, I know, whenever you have the opportunity to talk to users, right, and work with them. So I know in Red Hat, of course, like you would have the chance to be on customer engagements and work with people who use it in a specific project context to understand what's going on for them. What I always enjoyed was when I did, or I still do it, when I gave conference talks. I've always felt the best thing was like when people came and asked questions, because then you realized, oh, okay, this is actually how they are using it. And then I learned, okay, so maybe those abstractions which we have found so far, they are not the right ones. Or if you want to build it out, okay, those are requirements people have, and this is something which we should accommodate for. But yes, having this hands-on experience of using it, I would say that's super important to build something meaningful.
I'll make this suggestion to you and to anybody else who's watching it. I always told people, if you want to see how your product is being used, go to a training class.
Right.
You will
Yes.
you will see it through those beginner eyes, and you will see every single thing that they don't quite understand, everything that's difficult to understand, everything that you maybe messed up on or need to improve on. And nobody's ever taken me up on it, but they should, I think.
Yeah, no, definitely. And yeah, I mean, in particular, if you work on those libraries, right, like Hibernate or Debezium. I mean, Debezium is maybe a framework more, but something which you do a release and then you kind of put it out there and people start to use it, right? So you can quite easily be a bit disconnected, I would say, from the user base. So yes, whenever you have the chance to, I don't know, do a training or be part of that, work with actual users, people should take this opportunity.
So the next part I wanted to go back to was you were talking about the Hibernate ORM or
Right.
OGM, something like that.
Oh, yeah.
Where you were
Yeah.
doing things like mapping Mongo and that sort of thing. And it was interesting you brought that up, because I don't think that's a problem just of Hibernate. That's a problem of how do you represent this thing that people have went kind of crazy with a schema. I still believe that even though you are using something schemaless, that you still need some sort of schema sanity in there,
Oh yeah.
because you kick the can. You kick the can a little
Right.
bit where somebody else somewhere down the road has to put some sort of schema in play.
Yes.
Do you think that that was part of the problem?
Um, I think that actually was a bit of our selling point, even because, well, in Hibernate, if you use it the canonical way, you actually define an object model, right? So this actually then takes this role of defining your schema. It's just like you don't express it in DDL and you express it in your object model, your Java object model, like twice, but instead you only actually express it in your object model. And this totally was one of the things where we said, okay, we also had the same observation as you, this schemaless nature. Just because a database doesn't strictly enforce some sort of schema, it doesn't mean that there is no schema, right? I mean, in most of the times there is a schema. I think the exception is like very generic key value kinds of use cases, right? So I don't know if you have like product data where you, then it may be some sort of like key value stuff where you have sizes or colors or whatever. You don't need to express this in your object model. It's more like generic path through key value data. But most of the times there is an object model, and this is also true with MongoDB or those other stores. No, I think the biggest reason why it wasn't a success is there was a mismatch between how Hibernate works, which is like inherently stateful, and the those databases which typically don't expose like transactions or a notion of a session to you. So I think this was the biggest problem there was, because I mean, if you are familiar with Hibernate, you will know there is this notion of, for instance, a first level cache, which means you start a transaction in your database, you aggregate all kinds of changes, and then at some point when the transaction gets committed, you flush out this first level cache and you track what has changed in your object model and you write out those changes efficiently back to the database. And well, this requires your database to have transaction support, right? And at least back then, MongoDB didn't have like cross-document transaction support. So this meant this was just like a leaky abstraction, I would say, because what we did, like aggregating stuff in this first level cache, there was just no way of writing this safely to the database. Now, there is also things like a stateless session, Hibernate, and so on. But I feel like this general mismatch of concepts, I felt this probably was what made this not a huge success.
So one of the interesting parts of your career, you kind of mentioned it, is when you have 10 years of experience. Let's say you're trying to interview or you're trying to tell somebody about this. How would you recommend people break it out or help people understand what you've done over 10 years?
You mean in my personal situation, just me?
Yes. For example, when you interviewed at Decodable, how do you take 10 years and say, this is what
Right.
I did over 10 years?
Oh yeah, I see what you say. I think I mostly break it down into those two parts. Really, like I mean, because it was pretty much exactly those two halves. First 5 years, Hibernate and this ecosystem. Second 5 years, Debezium, and for instance, for Decodable, definitely the Debezium experience was more relevant. So we focused a lot on that. But yeah, I tend to think about it in those two big chunks, and then of course, I mean, I as much as I remember, I can of course drill down into specifics and talk about the details.
Okay. And so then there was the acquisition. So kind of following that acquisition line, there was Red Hat was acquired by IBM. Red Hat had
Right.
also acquired various things before that. What was life like after that IBM acquisition?
Yeah. So maybe on that one, I should say the part of Red Hat where I was at, it was called the middleware team, I would say, and this actually was its own company back in the day. So this used to be a company called JBoss. I'm sure you have heard of it. So they built their own application server, and actually the way how Hibernate came into Red Hat was like the Hibernate guys at some point they were hired by JBoss to work on Hibernate. Then JBoss got acquired by Red Hat, and at some point, well, IBM acquired Red Hat, right? And I'm just saying this because I always felt like within JBoss or middleware, we had our own culture, and it was a little bit like the JBoss way of doing things. And so I felt, at least on the level I was at, I didn't really sense a huge difference when the IBM acquisition happened. So this was always the premise of the acquisition, that Red Hat should remain independent. It should, keep doing its thing. And now I'm obviously not part of the senior executive suite at Red Hat, so I'm sure they had, many interactions with IBM people. But on the level I was at, not that much really changed. So we just kept doing our things. Yes, sure, maybe there was some collaboration with a specific IBM teams or projects. Also, a few folks came over. So, for instance, working on Java, so some of them moved actually over to Red Hat or working on Kafka. But from my day-to-day job working on Debezium, it was pretty much the same as before.
All right, let's go deeper into Debezium. So, what is Debezium?
Right. What is Debezium? So, Debezium, it's a tool, a platform for change data capture. So, what that means is it taps into the transaction log of your database, like Postgres, MySQL, SQL Server, Oracle, and so on. And it will extract the change events whenever something gets written to this database. So for each insert, for each update, for each delete, Debezium will capture this event. It will, take note of this intent to change a data item, and it will publish this event, for instance, via Apache Kafka. So it allows you essentially to have real-time notifications for your data in your database. And this opens up a ton of use cases. We can talk about that at length, like just, of course, like replicating data, taking data from one database to another, taking data from a database into like your cloud data warehouse or a data lake, updating your search index, updating a cache. People use it for data exchange between microservices, for building audit logs, because if you keep those change events and you put them into Snowflake one by one, it's like an audit log. So there's a ton of use cases for change data capture, or CDC for short. And Debezium is a open source implementation of CDC.
And to help people understand that, Debezium went both at change logs as well as queries. Is that correct?
Not so much queries. First, let's talk a little bit about it. So, the general concept is it extracts changes from the transaction log. And when I say that, that's actually a bit hand wavy, because what exactly happens depends on the specific database. So, for instance, in case of Postgres, Debezium acts like a replication client, like a replica, and it gets streamed all the changes to it. So we don't actually go to the Postgres val and access that file or those files ourselves, but we make use of that replication protocol. But then that depends for all the databases, right? For instance, in case of Cassandra, Debezium actually does process the log files themselves. But it always is about reacting to transactions which are written to the database. And there's two angles, I would say, where queries play a role. The first one is, well, if you set up such a CDC process, and many times you want to do a backfill of your existing data. So this means if you have this table with your 10 million customers, you won't have all the events for inserting or updating those 10 million customers in your transaction logs, because the database will discard the transaction log segments once it doesn't need them any longer, right? So if you want to actually start with a backfill and export all those 10 million customers from your Postgres into BigQuery or Snowflake or what have you, well, then you want to do this initial snapshot. And this is where Debezium would then use queries to scan those tables which you are interested in, select the data from there. And then once this snapshot is complete, then it would start to read from the transaction log exactly at this point in time where this read transaction happens. So making sure this transition works correctly, that's actually a key part. So that's the one part where queries play a role. And then sometimes, yes, people are interested about, well, we would not only like to subscribe to changes in a table, like getting inserts, updates, deletes, we also would like to subscribe to query results. So let's say I select from my customers table, I do some filtering, I join the address table in, and I would like to subscribe to changes to that query result. And this is something which you cannot do with Debezium or change data capture, because again, it just is about capturing changes from the base table. So what you want to do, if you would like to subscribe to query results as they change, you would have to use some kind of incremental query engine for instance, like Apache Flink, which then would take those raw change events coming in from those different tables, and then it would incrementally recalculate any queries you have defined. And then, I don't know, if you have this select star from customers in the simplest case, if I do another insert in this base table, then Flink would ingest this insert and it would emit this as another result to this standing query. But again, it's not something which you would use only, or which you could do only with Debezium.
So that's an interesting distinction, because oftentimes developers are doing a polling mechanism into their database because they didn't have a way to get an event. Do you think that there's a point where it makes sense to do that transition, or do you think that it's much more nebulous than that?
You mean when I would move, or how I would choose between a query-based CDC and a polling-based CDC approach and something log-based? Yes.
Well, not just polling, but let's say you have a program that program is polling for changes, whatever those changes, doing whatever with those changes.
Right. I mean, I would say, and of course now I'm biased because I've worked on Debezium, which is a log-based engine for so many years. But I would say whenever you have the opportunity to use something based on logs, then I would do it. And there's a few reasons for that. I mean, the first reason is it is guaranteed to give you all the changes which happen to your data, right? So let's say, I know you have a customer record and you update it multiple times in a close consecutive order. Now, if you have a polling-based approach, you are just not sure that you would capture all those intermediary updates, right? So let's say you poll once every minute. If I do 2 updates within 30 seconds, I would miss one of those states or one of those updates. Whether that's important or not, I mean, it depends on your use case. But generally speaking, if you don't want to miss any updates, that's the one thing to keep in mind. And then, of course, you could say, okay, let me poll then more often. Let me poll every second or every 10 seconds. I don't know. But, again, it would just not be a certain. And also, of course, like it would be a huge performance overhead, right? I mean, if you were to go to your database and poll on this customer's table like every second, you probably wouldn't do this for too long. So that's the one thing. With a log-based approach, because you get the append events from the transaction log, so by definition, you have all the events there. The other thing is, or one of the other things is, it is agnostic to how your data model is designed. So if you want to do something polling-based, well, you need to have a way to identify any changed records, right? So you need to have some sort of last update column, for instance, which you then can use as a marker to identify those records which have changed since the last time you ran your polling query. And this just means you need to prepare your data model for supporting this use case. And whereas with a log-based approach, well, it can capture changes from any table. It doesn't have any implications on how you design it. And maybe the last thing to mention on that one, there's a few reasons more, but the last one to mention is you also can capture deletes. If you think about it, how would you capture deletes from a table with a polling-based approach, right? If it's just gone from the table, you poll the next time, you would have no way for finding out which rows have been deleted. Whereas if you do it based on the transaction log, but also a deletion actually is an event which gets appended to the transaction log, so you also will be able to capture those. Now, I should say there's one situation where you would want to use, or where you probably want to use a polling-based approach, and this is if there just is no CDC or no log-based CDC connector, because as I mentioned, there must be a bespoke connector for each database which we want to support, because those APIs, those mechanisms, file formats, and so on, they all differ. So you cannot implement CDC once and be done for all times. So if there is no CDC connector for your particular database, well, then you could first of all try and develop one and contribute to Debezium, or you would have to go the query-based route.
So you mentioned there's lots of different use cases. What are the top 3 use cases for Debezium?
Top 3 use cases, definitely propagating data from operational databases into data warehouses, so BigQuery, Snowflake, or real-time analytics stores like Apache Pinot, ClickHouse, those kinds of things, because it allows people to do queries and to gain insight from their data, which they couldn't do with an operational database, right? So that's the one. And to give people an idea, in terms of latency. So I know of people who had end-to-end latencies from their production MySQL clusters through Debezium, through Kafka, into Google BigQuery within less than 2 seconds. So they always had the latest, very freshest data in their BigQuery system, and they could do analytics there. And what's interesting is once people have this experience, they see, oh, wow, actually, I can have this super fresh data in systems like a data warehouse. They want to have it for other things as well. So it kind of is like, you got to experience it once, and then you want to have it elsewhere. So that's, I would say, feeding data into data warehouses, analytics stores. That's, I would say, the most relevant one. Then there is a lot of people who use it for updating search indexes like OpenSearch, Elasticsearch, because, well, you want to do full text search on your data. Most of the databases, maybe they provide some means of full text search, but it's not what you would get with a bespoke and dedicated search service. So you want to do like proximity search and like, fuzzy search. You want to display results. You want to highlight matches in your results and all those kinds of things. So you want to use a dedicated system. And of course, you need to keep the search index in sync with your operational database, right? And this is something where we see a lot of Debezium users, and then actually also using this together with something like Apache Flink as a stream processing engine, because in a document store like Elasticsearch, well, you can organize your data in a nested and in a hierarchical structure, right? So let's say I have a very basic object model in a relational database with purchase orders and order lines. And the way I would model it there is I would have two tables. I would have a table for purchase orders. I would have another table for order lines. I would have a foreign key relationship. And if I want to examine an entire purchase order with all its lines, well, I would do a join, and I would have like a relational result set. So that's how I would do it there. Whereas in something like Elasticsearch, you would like to put all this data from one purchase order into one document in a single index, right? So you would probably would have like an array. Exactly. It would be denormalized. It would be like an array of order lines within your purchase orders. And this is something which people often use then with Apache Flink. So they take those change events for the two tables from Debezium, build this join, and then sync this data into Elasticsearch. That's the second one. And as you asked for the top three, what else would I give you? Yeah, microservice data exchange, I think, is also a common one. So, when people move to microservices, of course, the idea was, well, we don't want to share databases across services, right? So if I have a service for my purchase orders, I have a service for my customers, I have a service for, shipments, they each should have their separate data stores. You don't want a couple systems on the data store layer. And of course, still those systems, they somehow need to collaborate, right? If a new purchase order comes into the purchase order service or into the order processing service, well, at some point you want to notify the shipment service that, okay, there needs a shipment to be built. And now the question is, how do you do this? Because there's this challenge. Well, this order service, it needs to probably update its own state. So it needs to persist the data in its own local database. And at the same time, it would like to use something like Apache Kafka to notify this other service. So it would like to send an event there and tell the shipment service, hey, there's this new purchase order. And how do you coordinate those two things? How you make sure that they are actually applied with transactional guarantees, right? Because what you really want to avoid at all costs is you have updated your own local state, but then you somehow miss to send this message to this other service. Or the other way around, I guess it's even worse. You tell the shipment service, hey, there's this new order, but then you fail to persist it in your own database, and your overall system state is just messed up. And actually, well, at least until Kafka can participate in something like distributed transactions, there's some work around it. But until then, change data capture actually is a good way for solving that problem, because what you would do is you would have your order service just perform its own local transaction. So it would go to its own database, persist the data there. And then you would CDC to ingest the change and drive the update over to the other service based on the changes from the database. Now you don't have this issue that you have those two resources which you try to write to at once. You only ever write to a single resource, and it's eventually consistent.
So you pointed out something important that I want to go back to, and that is
right.
Kafka's transactions only do Kafka to Kafka. As soon as you go to mutate a third-party system, you lose transactionality. And so what Gunnar was referring to is there's a KIP out there for Kafka and whatever system to participate in that two-phase commit. How long that will take, how performant that will be is a different question. But
exactly. And even then, I would argue, I would not necessarily recommend to make use of that for that particular scenario which I described, because it has an important implication on your availability of your overall system. Because if you want to make use of this distributed transaction approach, well, you need to have your database and Kafka, right? They both must be running, accessible, and so on. Whereas if you do it via CDC, you go to your database, and then you drive the update to the other servers asynchronously. Well, you just are required to have your database available when this first request comes in. So there's an implication on overall availability there.
Have you seen a use case that surprised you?
For CDC, I'm sure. I mean,
for Debezium definitely as a whole.
Right, definitely. I mean, one thing which we do it ourselves at Decodable, but I only learned about it briefly before I joined, so it was new to me back then, is to use it in a SaaS. When you build a software as a service, typically you have this control plane where you take care of what users express in terms of their intent. Okay, those are the resources they want to create. Like in our case, those are the connections they want to build. Those are the pipelines they want to define. So all this happens in this control plane service, which has a database. And then, of course, at some point, you need to materialize this intent into your actual data plane. So, if it runs on Kubernetes, you want to materialize Kubernetes resources out of those configuration artifacts in your control plane. And CDC, and actually quite a few cloud providers make use of that to build their internal architecture is one way for doing that. So you use CDC to, ingest the changes, subscribe to the changes in your control plane database, and then drive those updates in your data plane. So that's an interesting one, I think, which is relatively new to me. And one which I also like is, and I definitely was surprised when I saw it the first time, is, so with Kafka, there is no means of having a scheduled delivery, right? If you send a message to Kafka, well, it will be consumed as soon as there's a consumer willing to consume it. But sometimes you want to have some kind of scheduled delivery. You want to send a message, and then you want to make sure it gets processed like in 1 month from now or at a specific point in time, right? And there's an interesting way for doing that. So essentially, people write, let's call them jobs, write those jobs into a database, and they have a temporal column which tells when this message should actually be sent. And then they have some sort of scheduled job which, runs every second or so, and it actually updates those messages which are due now, so whose to send timestamp has been reached. It updates them, and then Debezium will capture those updates, and it will send those messages then according to that scheduled date out to Kafka. So I feel that's an interesting and elegant way for doing something like scheduled delivery in this ecosystem.
Or you could use Pulsar and have it built in.
Okay, maybe. Yeah, I don't know. Do they do that? That's
it's built in.
Could also be an option, of course.
Yeah,
and I'm sure it's going to be at some point in Kafka. But when I learned about it and you asked about surprising stuff, I felt that's an interesting one.
I haven't seen any KIPs around for scheduled delivery. No, I don't remember seeing anything about that. But yeah, it's built into Pulsar.
Do you see Pulsar a lot, like in your experience?
I'm not seeing it as much as I'd hope, to be honest. But I'm still seeing it. But it's whenever people, I think what's happened is people were used to the streaming side, and then they forgot about the messaging side. And so they'll do messaging in a streaming sort of way, as you just mentioned with the CDC, and do a bunch of Kafka backflips, is what I've come to call it. Is you have to do all these workarounds for Kafka, which can work and may work, instead of saying, okay, well, do we do the workaround, or do we do something that has a built-in Pulsar? And more often than not, people are doing the backflips. which is unfortunate, I
I
think.
see. Yeah. What I do know is they also integrate with Debezium. So I mean, I think there's the thing Pulsar.io, right, which is their connector story, and
Yes.
there's some wrapper around Debezium, so it's also used there.
Well, you mentioned Decodable, so just as a foregleam to everybody, we're not going to be talking about Decodable a lot in this episode. We're going to be focusing on the Billion Rows competition, but just so we understand, what is Decodable?
Right. So Decodable is a SaaS, as I mentioned, a software as a service, a fully managed service for real-time data movement. So it's essentially takes things like Debezium, but then also all kinds of other source and sync connectors for taking your data from A to B. So you could, in the shortest sense, you could say it's a real-time ETL platform. The twist is it's based on Apache Flink, which means it gives you also, means of transforming and processing your data on the fly. So maybe you want to start with something like, as I mentioned, this simple use case. Okay, I want to take my data from Postgres to Snowflake. So this is something which we could do just by you, or which you could build on Decodable. So you would just configure two connectors, Postgres source, Snowflake sync. You would connect them via what we call a stream, and then you would have this end-to-end pipeline. It would run for you in a fully managed way. You wouldn't have to think about scaling it and procuring hardware or services or whatever. So we would take care of all that. But then well, oftentimes there's a notion of processing, right? So maybe you just want to filter some data. Maybe you have some sort of PII, personally identifiable data, which you want to remove from a change event stream. So that's something you could then do on Decodable using a bit of SQL. Or maybe you want to, normalize date formats, convert IDs into string constants, so all those kinds of stateless conversions. So that's something which you could do with a bit of SQL. But then also you could actually go all the way to stateful processing. So if you want to do joining or windowed queries or aggregations, that's also something you could do. So coming back to this pipeline from two tables in a Postgres database and going into a single index in Elasticsearch or OpenSearch. So that's something which you could easily do in Decodable with those connectors and then a few lines of SQL. So that's what we do, real-time ETL, real-time data movement, and then a seamless transition into stream processing all the way up to running your own Flink jobs. So maybe this is something you want to do, just have a managed Flink experience. That's the other end of the spectrum of what we support.
And you can run a custom jar. So not just a UDF, but your own Flink jar.
Exactly right. So you could also give us your own Flink jar. We call this custom pipelines. And so we would run this for you. And then the idea as well, it still connects with the managed decodable infrastructure, if this is what you want. So maybe you still want to use those managed Debezium connectors. You don't want to have them in your Flink jar. So then this is exactly what you can do. We have an SDK, which would then allow you to connect your custom job with those managed connectors. And essentially you would just have to plug in those holes where you really need to have your own bespoke logic. Maybe you want to call like a remote service or something which you cannot do with SQL, obviously. Well, maybe we could add an UDF, but we don't have that. So you could then plug in your custom Flink job just for that part, and then again take the data into either other SQL pipelines or connectors.
And I didn't define UDF. UDF is a user-defined function. So you would write your own code and put that into SQL, and that's how you could run some custom. But the difference here is, could you run your own pipeline? So you would make your own graph, your own DAG. So
exactly.
Okay.
Exactly right. So yes, that's what we do.
Well, let's get to whiteboarding and talking more about the Billion Rows competition. So to start off with, what is the Billion Rows competition?
What's the 1 billion row challenge? Actually, this is a challenge.
Challenge.
Yeah, so right. No worries, that's good. So let me, and I for the benefit of everybody, so it's the first time I'm doing this whiteboarding thing, so bear with me. So yeah, it's a challenge which I put out there at the beginning of the year. It ran for the month of January, and the idea is it's quite literally there in the name. So it's about processing a file with 1 billion rows. So there's 1 billion rows. And it's about temperature measurements. So there's a very simple format, and it's always the station name, the weather station name. So let's say something like Hamburg, semicolon, and then a measurement value. Well, 32.7. So you have those measurements, and you have 1 billion rows of those. And the task is, well, aggregate the values from this file and group the readings by station name. So there's, Hamburg, Lisbon, whatever you have, and calculate the minimum value, the maximum value, and the mean temperature. So you want to do min, max, and mean value. So that's the challenge. That's all you got to do. And there's just the one caveat. You have 1 billion rows of those. And of course, the challenge is to make this as fast, as efficient as possible. So that's the idea in a nutshell. And I put out this challenge. I thought, it would be an interesting experiment. I started actually thinking about it. Well, I started thinking about it for quite a while ago. But then after Christmas, between Christmas and New Year's Eve, I was thinking about it, and I was like putting together the actual challenge, and I started on January 1st. And I thought, well, maybe a few folks will participate, a few of my friends will be interested. Then it kind of went viral. So people in the Java community were interested, but then also way beyond, right? It went into .NET, and there people built implementations in COBOL, or Fortran, and C++, of course, Go and Rust, and databases like Postgres and Snowflake. So in Snowflake, somebody did like the 1 trillion row challenge, because like 1 billion is nothing for Snowflake. So yeah, that was the task, and then, well, all those events unfolded where people tried to make this as fast as possible.
That is pretty cool. So I think I saw it probably New Year's Day or maybe the next day, and I thought, oh wow, that's really cool.
Right.
Simply because it was very novel and very creative. But what's key about these projects is they're fiendishly simple, but the implementation of them, there's a lot of threads that you can pull, and that was what I found so interesting about this.
Yes, definitely. So I think this is, what explains. I mean, again, by no means I would have expected that it would be that popular, and had I known, I would have, be much more thorough about preparing it and everything. It was really like a surprise for me. But yeah, I think the reason, or one of the reasons why it was so popular, was that, well, as you say, it is easy to explain. So you can explain it in 1 or 2 sentences to everybody. You don't have to be a IT person or whatever, software engineer. You understand this problem easily. And still, it has lots of potential, right? So over the entire month of January, because the challenge ran from January 1st until January 31st, for the entire month, people kept working on it and kept improving it and shaving off second or millisecond by millisecond. And I believe even by the end, people had some ideas still. At some point we just had to do like a cutoff. But yeah, so it had enough potential to be engaging and open up enough room for exploring all kinds of avenues for making this really fast.
It is. It's and you did all of this open source, so that was really interesting to me as well. Nobody could try to hide their implementation.
Oh yes, absolutely. Yes, I did that very much on purpose, because for me, well, I had 2 goals, I would say. The first one was, well, I mean, I'm a Java person. It's the language I'm familiar with. It's the ecosystem I feel comfortable with. And sometimes there's still those misconceptions, like it's slow or it's like old school or whatever. And I wanted to provide a showcase for telling people, hey, look, actually, it's really fast. You can do something which is like really competitive, and you can take it really far. So that's the one thing I wanted to make the case for, helping to evangelize Java, if you will. And then, of course, I wanted to provide means for people to learn something new, and for me to learn something new. I mean, I wanted to learn about this stuff, but also to provide the opportunity for others to learn something new. And this is exactly why it's all in the open. So, this leaderboard and like the competition, who is the fastest, to me, it's more a means to an end. I mean, yes, I understand it. We all are competitive, more or less, I guess, but it's very natural. You want to be up there and you want to be the fastest. But really, for me, this was more a forcing function to, allow people to learn about that stuff. So this is exactly why you could take inspiration. It was explicitly mentioned in the rules. You can take inspiration by others. you just shouldn't take somebody else's implementation and like resubmit it, because I mean that wouldn't provide any value. But people gained insights from others, and some even teamed up. So the fastest one actually, it's like 3 people who worked on that together, which is totally cool. So this was exactly that. Yeah.
You did bring up something interesting, and that was the perception that Java's slow or Java's old, and nothing that I've seen in this sort of implementation is slow. I mean, the spoiler alert is that the final time was 1.53 seconds.
Right.
It is quite fast, and you can do some pretty interesting things in Java. Do you think it helped dispel that myth?
I would say so, yes. I mean, people literally said that, and many people said that. So yes, wow, I didn't expect this to be possible with Java, or I didn't, or maybe I have looked at Java the last time 10 years ago, and this challenge made me look at it again and see what's doable these days. So yes, I think it helped. I mean, I have no idea how impactful it is in the end, but I got lots of, really positive feedback. Also, just looking at the numbers in other languages. I mean, the thing is, I limited this to Java for 2 reasons. Well, the one was, it was just, okay, I mean, I had to evaluate all those entries, and I had to run all those entries on on some environment. And well, I'm not familiar with, let's say, Rust toolchain or other languages toolchain. So sure, I could figure it out, right? But it would mean I would have to install like a COBOL toolchain if I wanted to install it to evaluate a COBOL entry. So it's just something which I felt I couldn't do. Then again, I wanted to make it about Java, and maybe I also this little bit of like a notion of exclusivity, or maybe this also was actually attractive to people. And oh man, okay, we also want to do it. And then we have so it's all in the GitHub repo. And we have what we call the show and tell in the GitHub discussions there, and people, put hundreds of comments with their own implementations in other languages to showcase those. And Java is doing really well there, right? So I don't know, maybe there's something which is in C like a little bit faster, but it's definitely really up there and absolutely competitive.
So speaking of the discussion, one of the things that really cracked me up, and I think I either saw it on Reddit or maybe it was LinkedIn, where people said, "Oh, you're just getting people to do this so that you could rip it off for Decodable."
Oh, right. Yes. I mean, the thing is, how much work I spent, how much work I put into this during January. I mean, for the first 2 weeks, I haven't done anything else besides running this challenge. And then even for the second half of January, I spent like every day in the evening, I spent like 4 hours or so. I spent all my weekends like doing it. So if I actually would have had this problem, I think I would have probably solved it like 10 times faster than running this challenge. But I mean, it's a nice idea. So no, it was not that. And people had other, what I call like conspiracy theories. So one of them was, well, it's actually an advertisement for GraalVM, because actually many of the fastest entries use GraalVM. So it's not that. I mean, I think for them it was also a nice marketing opportunity, to showcase the benefits which there can be. And Thomas Würtinger, the project lead of GraalVM, he was one of the most active participants, and he is part of the team which built the fastest one. But so no, it was not a plug for GraalVM. It was not a plug for Epic, which is the CPU I'm using. What else? People had a few ideas like, yes, is it a hiring means of hiring? It also was not that. It really was just like an innocent, fun thing, which I thought I would put out for a couple of people. And well, then it actually were a few more people than who participated.
I think it's a reflection of how jaded we become as a group, of always looking for something behind it. You can't do something altruistic, Gunnar. You always have to have something.
I guess in a sense.
And it's sad because the people who put a lot of time in this, for example, me doing this show or you doing this thing, it isn't a huge moneymaker. We're doing it out of the goodness of our hearts. I genuinely want to see this industry change, and this is one of the ways we can do it. We can do it by getting deeper, by not doing these really cursory things. That's not going to push us forward.
Right. Yeah. No. Absolutely. for me, again, the goal was real to, learn something new, have fun, and inspire others to do the same. And I think it was successful. But yeah, I don't know. Maybe it's surprising to have this sort of innocent pleasure these days. I don't know.
So what did they end up winning?
Oh yeah, so that's also actually worth mentioning. So I mean, my initial idea, and again, this all was something which I had started on my own between Christmas and New Year's Eve. Then it started in January. It really took off, and I realized, okay, I will have to spend quite a bit of time on it. So actually, Decodable and Eric Semmer, our CEO, were super supportive of it. So I could, spend like the time on running it. And also they sponsor actually some prizes. So that's the last thing which I'm doing right now. So I will do a T-shirt, a 1BRC T-shirt for the top 3 participants, and I will do a coffee mug, 1BRC coffee mug for the top 20. So that's still what I'm gonna do. Thanks to Decodable for sponsoring that. And also, I should say, they also sponsored the evaluation machine. So I had quite a beefy server, an AMD EPYC 32-core machine, which cost me like 200 euros or so. Still got to expense this. But yeah, so they also sponsored it. And actually, just to give you one idea of the things I learned myself while doing this, and I learned a ton. But initially, I had started with a environment, a virtual cloud environment, and I thought, okay, it has a dedicated CPU, so that's what I looked for, so that I don't suffer from noisy neighbors or whatever. Then the challenge also is designed in a way that the file actually it gets always retrieved from the page cache. So I thought, okay, I would be fine. I/O bandwidth, disk speed doesn't matter. So I felt comfortable about this, and that's how I ran this thing initially for the first few days. And then I woke up at some day, and all my measurements were off. Like all the entries were like twice as fast as before. And I was, man, what's going on? I mean, I haven't changed anything, and it has dedicated CPUs. So what's the story? So I opened up a support ticket, and they told me, well, they moved the workload to another host machine. So I don't know, maybe they saw there's like lots of load on that machine. So I don't know, let's do something good to the person. Let's move it to a better, more modern host or whatever. But yeah, for me, it was actually not good because all my measurements were off. And then, well, I got a dedicated server, big machine. And actually, when running on all those 32 cores, 64 threads with turbo boost and everything on, then the fastest one is actually 0.3 seconds, so 300 something milliseconds. So it's like really impressive for this data set, which is 13 gigabytes of size.
So let's go to the second Jamboard,
right?
And give us a simple implementation or a naive implementation.
Right. I mean, so maybe we can talk a little bit about 3 things, I would say. So let's say, because this is like the dimensions where people, I would say, optimized. So the first thing is, I would say, and sorry for my writing.
Make sure you're on whiteboard 2, not 3. I can't.
Oh, hold on. Yeah, thank you so much. Oh, I see what you have done there. Okay, got it. So I literally bought this stylus for the session, by the way. So I'm still practicing. So let's talk about 3 things. So the first one is like parallelization. Or how do you write it? Something like that. And memory access. So let's talk a little bit about that. But because, I mean, I think that's the most apparent thing you would think about, right? So you have this file, it has 1 billion rows, and the initial evaluation machine had 8 cores, and also when I had the new server with 32 cores, I said I will run everything on 8 cores by default. So the obvious thing to do is you want to parallelize this, right? So you want to take 8 threads and process 8 chunks of that file in parallel. And I mean, that's an obvious thought. So that's what people did. And now there's a few interesting things to that. I mean, the thing is, how do you actually split up this file, right? Because if you divide this, I mean, you would take the entire file size, you divide it by 8, so you have 8 chunks. but then, of course, you might be in the middle of a row, right? So I don't know. Let's say you end up at this marker, and now what could happen is maybe the position looks like this. So you have Hamburg, this value which we had before, right? And now your position is here. So you cannot start processing there, right? So you have to find actually a row delimiter. So what most people do is, right, so you probably would go backwards just to make sure like your chunk isn't too large. So what people would do is they would go back to the previous new line and split the file then up there, right? And then they would start with the next chunk. They would start up here. So that's one thing, splitting up this file. And now what's interesting there is, well, you have 8 cores, so the obvious thought is to split it up into 8 chunks, right? And this is how people started. But then they realized, well, actually, you always have one of those 8 threads which takes the longest time. So one of them will still be processing, and the other ones are already done. So you lose out a little bit in terms of wall clock time, right? Because, and I should say that the measurement of the challenge was you run the program, and the time is taken until you have printed out the result. So if you have a part of that time where 7 out of your 8 threads sit idle or cores sit idle, it's just wasted effort, right? So what people actually did then is they did 2 megabyte chunks and implemented some means of work stealing. So whenever one of the processes was done or threads was done, it would take the next 2 megabyte chunk. And this just means you have a much more even distribution of those chunks across all the cores. You don't have this effect that one of them like will be running and the others already are idle. And now the reason why it's 2 is, so I think they found it out heuristically, but apparently, well, I should say this machine had 16 megabytes of second level cache. And if you have like 8 cores and 2 megabytes of chunks, it's 60 megabytes. So it just makes the most efficient usage of the second level cache. And this is how they ended up at that. So that's actually what people did in the end. So that's, I would say, parallelization. Now, the question also is...
So before you move on off that, one thing coming from a Hadoop background, Hadoop would break right here, not right here. Okay. So when you were first talking about that, I was surprised that they were going backward instead of forward.
All right. Yes. And I can tell you why.
Well, I was gonna explain why in Hadoop, right, what it was. It was the HDFS. So you generally want this one to read ahead, not go backwards, so that it can start immediately.
Okay, I see. Yes, and the reason why here I think it's easier to go backwards is because, well, it actually relates how you access this file. And most of what people did is they memory mapped the file. So, they have this,
and so they went backwards. Yeah.
And the thing is, with the Java APIs until like 21 or so, you only ever can map 2 gigabytes at once in a memory mapped file. So if this marker here is at 2 gigabytes, you actually cannot go any further because, well, then your chunk would just be too large. So that's why they went backwards. Now, actually, with Java 21, there's this new 4-in memory mapped API, or 4-in memory API, where you actually can map arbitrary large files into memory. So you can do the entire 13 gig thing at once. But most of the folks actually didn't use that API. But so that explains why it is that way.
Okay, and I stopped you from talking about the memory access.
Right. Yeah. No. That's pretty much what I wanted to mention. Exactly that. So people which means of using or which means of memory mapping that file people used.
Okay.
Exactly that. So we are good.
And so what's number 2?
What's number 2? Right. Should we go to like a new one?
Yeah.
Or what should we do?
Let's go to number 3.
Let's go to number 3. Okay. Right. So and let me. How do I rate? Oh yeah. Thank you so much. So that's let's call it 2. And that's line parsing. So you have organized your work into 8 chunks or into reasonably sized chunks. You work on them in parallel. You are using up all your CPUs. And then, of course, the question is, how do you make this happen as fast as possible? And there's quite a few things which are like real tricky and which are probably a bit harder to explain. But let's use one of the techniques, and this is this entire notion of which is called SIMD. So that stands for single instruction, multiple data. So what that means is you can make you can use a single CPU instruction and you can apply it to multiple data items at once. And then it is just more efficient, because let's say you can apply the same operation to 8 bytes of this input line at once. Well, in the idealist case, it would be 8 times as fast, right? So, and to give like a rough idea of what could happen there. So, I mean, you have those lines, right? I mentioned that you have those values with the name, and there's a semicolon, and then the format was always like 2 digits, comma, and 1 fractional digit. So now, of course, you need to look for this semicolon, right? And you also want to look for where's the next line break. So you want to find those characters. And now what you can do in the most simplest cases, well, you could just iterate through that and then compare each byte. Is it a semicolon? Okay, then I am done with my name. Or is it a new line? Okay, then I have found the end of the line. I can build my temperature value. But that's actually not as fast, right? So what you could do then with this kind of SIMD instruction is, well, you could load 8 of those bytes into an array with 1 to 8. You could load 8 bytes into an array, and then you could apply some of those SIMD CPU instructions, which are exposed to you in Java through a new vector API. And you could, for instance, apply a mask operation. And essentially, it would tell you then at which of those bytes there is a specific character you're looking for. So if there was the semicolon here, you would have maybe an instruction which then gives you 00100. And so then, okay, at this 5th position, I have the semicolon. And you could then process this line by stepping, through it in chunks or in those steps of 8 bytes at once. So that's one of the things. And the general notion there is, well, of course, you benefit by being able to apply the CPU instruction to multiple operands at once, but you also benefit from or you avoid what's called branch misses. So essentially, if you have like if-else statements in your CPU and they always run in a pipeline, and it already executes future statements by speculation. And now, if you actually have this sort of branch misprediction where I know you were looking for a semicolon, so you do this if, but actually your if then doesn't return true, it returns false. Well, all the stuff which already is in the pipeline needs to be discarded, and CPU would have to fill the pipeline again. If you do this kind of stuff, and for instance, you also could, apply, the same thing with a single register, comparing multiple bytes as a single long, for instance. Then you have what's called branchless programming. So essentially, you do this sort of masking, and you never have if else is there. You never have branches there, and it just means you never have mispredictions. So that's one of the things which people also do. The code to actually do it is super dense, so I cannot really write it on the tablet here. So I would recommend people take a look at those fast implementations. But that's a general notion of how you could go about this. So SIMD, doing multiple things with a single CPU instructions, branchless programming. And also benefiting actually from multi-scalar execution. So essentially, if you look at one of the or some of the implementations, what actually happens there is, so you wanna step through this chunk, you want to process all those lines. And if you look at some of the solutions, they will actually have the same processing loop 3 times there. So they have a chunk, and so they have the first loop, which goes through a few lines at the beginning of this chunk. They have another one which maybe processes the middle of the chunk, and they have a third loop which processes at the end of this chunk. And all this is sequential code. So you look at the code and you have 3 while loops written after each other. So you would assume, okay, they are like executed sequentially, right? First the first one, then the next one, then the last one. But actually, if you don't have data dependencies between them, so if your compiler can actually detect, okay, those 3 while loops, they operate independently from each other, then again, this can be parallelized. And because those modern CPUs have those means of running those multiple instructions also in parallel. And this is then something which also some of people did. And again, it's a bit, by heuristic. So why is it 3 times? Well, because 3 times was, why is it 3 while loops? It was the fastest people found. Okay, if I do 4, well, it's actually not faster anymore. If I do 2, it's not as fast if I do 3. So that's one of the things you also can do. And I had no idea.
You actually saw that, and so you saw this implementation in the winning entry. By the way, there are those 3 loops that are in there.
Yes, right. So those 3 loops, they are exactly. So Thomas is doing that exactly. Yes.
And what is the third? Let's
what is the
move
third?
on.
Right. So actually, I want to mention one more thing here, which
Okay.
I found actually intriguing. And this is, if we look at this number parsing there. So the format is, we always have 2 numbers for the temperatures, and I said, the minimum is minus 99.9, and then the biggest one is 99.99. So if you think about it, there's 1,999 different values, right? So because there's also 0.0. So you have 1,999 different values. So what one person did is they actually came up with a perfect hash function for processing this value. So essentially what they do is they take those 3 bytes and take that resulting number as a lookup into an array. So they pre-calculate an array which has all those 1,999 values. They put them into an array, and they use this one here as the index for looking up into this array, and it's predefined so that there are no collisions essentially. So it's a perfect hash, and then actually that's a little bit faster than if you were to parse that value just by taking this as a lookup into an array. And I found it it's such a neat trick, and I was just fascinated somebody would come up with it.
Yeah, that is pretty ingenious. I wondered if there was some better way of parsing that out. I also saw for people that were you didn't mention this part of the parsing, but it looked like they were keeping this in bytes instead of dealing with strings there.
Oh yes, absolutely right. So you want to avoid creating strings as much as possible. So yeah, you keep the raw byte. There's some people who do let's call it like a flyway pattern implementation. So they actually construct strings, but they are backed by specific chunks of that, maybe off-heap buffer even. So because you can construct a string from an array, and now you can say, okay, I have this 2 gigabytes of byte data, and I could create a string which starts at offset 500 and has a length of 16. So and that's how you can actually work with strings, and they all are backed by this one large array, which maybe makes it a bit easier to digest when looking at the code. But yes, what you wanna avoid is like copying bytes and arrays and creating like new strings, and they are all like independent objects. That's what you don't want to do.
And that goes to why in Java equals and dot equals are 2 different things in Java.
Right.
Yes, let me describe that briefly. Why, if people are misunderstanding that. So if you're doing an equality check like you might do in Python, where you do an equals in Java is a memory address check, where, to what Gunnar was just talking about, if you're looking in memory, your memory could be over here and memory could be over here, and so they will not equal. So you have to do this dot equals in order to check that.
Right. I mean, it refers to the object identity, right? So you could have two strings which both say Jesse, but it's different objects. And if you were to do equals equals, it would tell you false because it's different object identities.
Yes. All right. Anything else on line parsing? Otherwise, we'll go to 4.
No, I think we can go to the next one, and there's actually an interesting segue between the two of them, and then it speaks a little bit to my, like, I guess, being inexperienced in doing that thing, because so as I mentioned, people or some of the guys used this perfect hash map for the values, and there it was perfectly fine because, well, you just have 1999 different values. So finding a hash function and using an array, that's perfectly fine. But for the values, actually, you cannot. Sorry, for the station names, you cannot do this. And now the problem is because there could just be so many. So I said it could be 100 bytes. So the name could have a length of 100 bytes, and any valid implementation must support any valid name, which could be between 1 and 100 bytes. Now the problem is, or maybe the mistake, I don't know, is I gave an example dataset generator, because the problem was, well, this file is 13 gigabytes, so there was no way I could, share it. And I mean, even then I would have shared the dataset anyways. So I had a dataset generator, which would allow you to produce your own 13 gigabyte file with 1 billion rows. And in the dataset generator, I had 413 different weather station names. This was just some dataset which I copied from Wikipedia, and I did like a normal distribution of temperature values, just to make it a bit more realistic. And now the problem was, well, people started heavily to optimize for this particular key set. So they would find an implementation which works very, very well for those 413 weather station names, but maybe not for other also legal names. And this is exactly, where some people initially try to do this kind of perfect hashing approach. They would take the hash from the station name, would use that value as an index to look up the name from an array. And then what you also need to do is you need to group and aggregate all the data, right? And this is actually why I'm mentioning this, is so you have 3, like aggregation. So for all your...
Are you on workspace 4, Gunnar?
Oh, sorry. Where should I be? I am
4.
Yes. Oh, so yeah, I am at 4.
Okay.
That's interesting.
It didn't show up yet.
What's going on? I see that. Yeah, and I see mine. That's weird. Let me do this. Oh, fascinating. Seems we're out of sync. I saw yours, what you wrote.
Oh, now it just came through. Okay.
Right, there you go. Okay, took a while. Right, so that's the thing. You have those values. You parse a new line, and now, of course, you want to aggregate that data, right? So you need to keep the data. You need to keep track of the data you have already for Lisbon, for Hamburg, and so on, so you can, recompute the min, mean, and max. And so you need to keep an aggregator kind of object for each of your weather stations, right? And now, if you know, okay, I only have those 413 different names, well, then you could construct a hash function which takes the hash for the name. This gives you an index into an array, and in this array, this is the aggregator for Lisbon, this is the aggregator for Casablanca, and whatever else names you have, right? Now, the problem is this only works if you never ever have any hash collisions, right? Because if let's say Hamburg and Lisbon would have the same hash, you would use this as a lookup into this array, and then you would intermingle the values, and it would be incorrect. And this is what initially happened. I didn't realize it, and some people made use of that. And then I clarified, okay, no, it should work for all kinds of data. So it also should work if you have 10,000 station names or whatever. So you cannot make any assumptions on the actual station names, because that would be just like cheating, right? So we clarified that, and then, well, what people ended up doing, well, implementing using a regular hash map is just too slow. It's not. It's a general purpose data structure, so it's not ideal for the purpose. So what people instead is they implemented their own aggregation data structures. And so the way that works is, so they do this hashing scheme. So let's say I have this array. So this has, say let's do it like this. And here I have, let's say, Hamburg. Here I have Lisbon. You have Berlin. Okay. So I parse my line, and I get an index which gives me which tells me where is this aggregation object in this array. And now there's a few things which could happen. So if I pass a value and there's no bucket at this element there yet. So then I know, okay, I'm the first one who wants to put an aggregation there, so I can use this. Okay, so that's good. Can just write there. But then if I actually calculate my hash, and now I arrive at a index in this array which already exists. So let's say I get here. So then I need to find out, well, is this actually the bucket I'm looking for? So my value is Lisbon. Is Lisbon the one here? So I need to actually do a comparison of the name, right? So I get there, and then I need to double check, okay, that's really my bucket which I'm interested in. If it is, then that's good. I can just add my new value there. And if it's not, well, then you could do something what's called like linear probing. So you would go essentially just to the next one, and either this is free, so you can use that, or you go as long as you have found yours, right? So let's say I know there's another one here. So my first index, I come here, so I check, is this my bucket? So is it Lisbon? If not, then I keep going. So is this the one? I would compare the name. So yes, then I can add it. Or if not, I would keep going until I have found my bucket, or I have found a free spot, and then I can put it there. So that's what I would say is how most people implemented this aggregation structure.
That's very interesting. There's one thing that you either you're not, maybe you're talking about it here, and that is the concurrency issue. So if you parallelize, you'll have concurrency issues. And so how, for example, with this hashing, how are people dealing with the concurrency issues?
Right. No, that's a great question. The general approach, I would say, is you keep those aggregations local to your thread. So because then you can safely aggregate your data there. And then at the very end, you do an aggregation where you collect all the data from all your worker threads and put it together. So you would have then, from all the 8 buckets, you would have values from Hamburg, you would have values from Lisbon, and so on. And then you would aggregate them once at the end, all the intermediary results which you have from your threads, exactly as you draw there.
Yeah.
What you really want to avoid is
aggregating
on one global structure. What's that? Yeah.
It's a straight MapReduce framework. So if you're not familiar with how MapReduce works, all of these are just, we're mapping over here with multiple threads. If we're using a distributed system like Spark, these would be different processes that we then aggregate together into a single reduce, or perhaps multiple reduces.
Exactly right.
But for something like what we're doing here, it has to be a single reduce, unless you're doing partitioning.
Right.
I wonder, did anybody do an actual multi-threaded reduce here?
Yes, I think somebody did that. There were a few folks. It's just like super slow, right? Because you have like contention all the time. You need to synchronize it or whatever. So it's just not very efficient.
Oh, really? I would think that there would
or
be
maybe
a way
I misunderstand
to
your question. Maybe you mean
no, you're right. It would be there would be some contention, but I think if you were to break up the key space, right, you might be able to deal with that by not having any contention for them.
Well, the thing is, you could still have each key in each could be processed by each worker, right? So, in each chunk, you could have values.
But I'm saying on the reduce side, you would have a multi-threaded reduce.
Oh, I see. Just for the final reduce. Yeah. Okay.
Yes.
I guess you could do it. I'm not sure whether anybody did that. I suppose it just doesn't make a huge difference in the grand scheme of things because it's just
it was
very
pretty
small...
fast at the end. It might shave off a few, maybe tens of milliseconds, enough to put you over some sort of small edge.
Yeah. And I think there's a few things like that where people still, could tune on. But at some point I just say, okay, let's call it, let's call it a month. I don't know if that's the saying, but to wrap it up and I don't know. Some people indicate they want to keep digging, so maybe somebody actually improves it further.
So, what were there any things that were interesting in the winning approach that we didn't talk about that you want to mention?
Right. Oh yeah, absolutely. There's a few things which we should mention. So the one thing to mention is, and maybe I know. Let's go to the next one. Maybe we
Go
do
to
this
5.
5.
Okay.
Right. So there's unsafe, because that's a bit of a, again. I hope it shows up for you in a bit.
Yes.
Oh, there you go.
Yeah.
So that's a bit controversial. So Java has this unsafe API, which essentially allows you, to do direct memory access without bounds check and so on. So if you do it wrong, you can like segfault and whatnot. So it's not something you would typically do in your day-to-day application. But here, actually, all like the top entries, they all use this unsafe API, because it just shaves off like the few deciding tens of milliseconds. And I'm saying it because this unsafe API is actually scheduled to be removed because, well, it's unsafe. So, your Java program can crash. Roy Van Reen, one of the top entries or top contenders, he had like dozens or more of seg faults while working on his program because he had his arithmetics wrong, whatever. So it's not typically what you want to do in Java. Now the question, of course, is, well, if this tool is so helpful for solving this task or a task like this, and it gets removed, well, how would we do something like this problem in a future Java version, right? So that's something would not be good if there was not a replacement. And so I think it will be interesting to see what comes out of it. And actually, well, the Java team working on this, they want to come up with new APIs, right, which are safe to use and which are like equally performant. That's the aspiration. And what Thomas from Gravia mentioned, well, maybe this challenge actually could be one of the litmus tests for asserting that whatever new API there is, it would be equally fast, right? So that also you could do a 1BRC entry, which is at the top of the game, also after the unsafe removal. So that I think is an interesting takeaway for sure. So that's unsafe. So then we need to talk a little bit about GraalVM. So let's talk about that. And now I think people are familiar with Java, I hope, in the sense that they know there's a Java virtual machine. If you implement a Java program, it emits Java bytecode, and then there's a just-in-time compiler which takes the bytecode and executes or compiles it down into optimized machine code on the platform you're running this on, right? So that's what Java does. And GraalVM, well, it's a project from Oracle, which does many things, but two of the things which are relevant here is, well, it provides an alternative implementation of this, what's called the C2 compiler. So this just-in-time compiler, which takes the Java bytecode, produces native code. So you actually can use GraalVM as your just-in-time compiler, and it can maybe do a better job than the traditional compiler there is. And some people use that. So that's one thing around GraalVM. So you can use it as a more modern JIT compiler, which, by the way, is written in Java. But then also what it does is it, so it's a JIT replacement.
I was just writing out JIT too.
Oh, yeah, there you go.
So they didn't know that you were saying some other English word that sounded like that.
Right. Okay, I see what they say. Okay, so there is that. And then it also can be used as an AOT compiler, as a ahead of time compiler. So this means, unlike what we have done for 20 years of Java, I guess, you also can use this to produce a native binary. Then you don't have your Java virtual machine anymore. The compile step gives you native code. And this is also what you can do with GraalVM. And this is actually also very interesting because, for instance, this starts up very fast because, well, it doesn't have to do the JIT compilation. It doesn't have, well, I guess it does do some kinds of class loading, but it's all optimized. So it just gives you a faster time to response typically. So if you were to build something like a Lambda function as a service kind of thing, GraalVM native binaries ahead of time compiled would be very interesting because you can have time to first result within milliseconds. Whereas if you were to start the JVM, it would take, 100 milliseconds at least, probably. And now what I completely did not expect, of course, is that we would go all the way down to this range where this actually would matter, because my own baseline implementation, so I'm the very last one in the leaderboard with my slowest Henry. And I didn't put any effort into it. I just wanted to do something which solves the task. So this runs within 5 minutes. And now we are down to 1.5 seconds, or even on all the cores, we are down to 300 milliseconds. Now, this means, of course, well, if you shave off 50 milliseconds or maybe more for starting up, it will be all the difference, right? So that's why also all the top entries are actually done in GraalVM. And I think the fourth one, the number 4, is actually a Java and traditional JVM. So big shout out to that.
I was surprised about that too, seeing a traditional.
Right. So they did a great job. And this actually, I can speak a little bit to why, because there's what's called the unmap trick. So the thing there is, so people, worked on that, optimized heavily and profiled, and they used perf stats and whatnot, to see where our CPU cycles are spent and all this kind of good stuff. And then what some folks started to realize is the program is done, the output is there, and still it doesn't complete for like another 100 milliseconds or so. And what turns out is actually to unmap this 13 gigabyte file takes like a little while, 100 milliseconds or maybe even more. Just waiting for this to be for the file to be unmapped from memory. And now what people did, and this is also what this Java entry does, is essentially they fork a process to, let's say, hide this unmap cost. So the way it works is they started program once, and then they fork a new one, fork a worker, and this worker, it's a separate process, but it uses the same I/O as this main process, which is the one which is measured in terms of like the execution time. So this worker process, it does the thing, it writes the standard out, and at this point in time, this one then can already conclude, and the measurement, it will receive the output on standard out. Whereas this one here keeps running for those 100 milliseconds or whatever to do the unmapping, but it actually, it doesn't count against the time we measure for this first process. And now people suggested that, and I was thinking, well, is it cheating, or is it what to think about it? But then I felt, okay, actually, I think it's something you could do also in, let's say, an actual application, right? And I mean, because this was like, for me, the guiding principle. Is it something you could realistically end up doing? And I would argue, yes. If you look for output on your CLI or whatever, well, then having some sort of separate process which does some sort of cleanup, I feel that's something which you could arguably do, right? And that's why I said, okay, we can do this. And this is also then what this fast Java entry uses. They also work with this separate fork for unmapping the file.
So let's move on to a kind of putting a bow on the project and go to 6.
Right.
How would you do this in the real world? And this is kind of a mix of some of the things that you've talked about. You talked about, hey, we had other technologies come and play. We had other languages do this. We have these other frameworks. You've even mentioned Flink, for example. Would you go and do, for example, these implementations in the real world, or would you prefer a framework, or what would you do there?
You mean if I actually had this task of
exactly.
just calculating? Right. To be totally honest, I guess I would just use something like DuckDB because it's super easy to use. I could parse the file there. I could run my SQL against, this CSV file, or maybe I would try and choose a different format. Maybe I would try and format the data as Parquet or whatever. So it's a binary format, more efficient to access. But actually, I tried it with DuckDB, and some other people also did it with DuckDB. And you don't get there. You don't get to 1.5 seconds, but you get to, and I would have to lie, but let's say 20 seconds, something like that, or maybe faster. But same ballpark, generally speaking, right? And I mean, if I had this job, I mean, would I spend 2 weeks for building an implementation which gets me down to 1.5 seconds? Or would I use a tool which can do it in 20 seconds? I mean, of course I would do that, right? I think that's the sensible thing. I would play with the formats, right? So if I were to do this on a regular basis, I would try and I would definitely convert it into Parquet or ever, I don't know, some sort of efficient binary format for sure. I wouldn't do CSV. But then again, if I were to work on an actual database, I mean, yes, then of course I would employ some of those techniques, right? You would all the SIMD stuff and whatever in the database core, you would totally do that to make it really, really fast.
And I think this is an important distinction of what you were talking about, that there's a point in which it makes sense. So here, are we optimizing for speed? And there's two different types of speed. There's speed of running, the actual compute time, but there's also a speed of how long does it take Gunnar to write this? And that's a whole different thing.
Absolutely right.
And then there's probably some other levers that we have in there that we can optimize for file format.
Yes.
Parquet is what you mentioned there. So there are some other levers. We also have other things. One of the funny ones that I saw, and you mentioned earlier, was Snowflake. So if my memory serves, Snowflake was 7 minutes to read the billion rows. Is that correct?
I don't remember it, to be honest. I think it sounds quite slow, to be honest. But I think in general, it's probably not an ideal problem for Snowflake because, and I think that's also an interesting general takeaway from this, that nowadays single machines are just so performant and scalable by itself. You just can totally process those 13 gigabytes and even way more on a single machine, right? So you could load it all into memory and do it super fast on a single node. Whereas Snowflake is about scaling out and distributed work in a cluster. And this means by the time where Snowflake would have distributed this workload, aggregated again, whatever, you probably would have done it 10 times on a beefy server with DuckDB already, or any local compute engine.
Yeah. So that's the other point to make here, is that distributed systems are slower than single machines. So it is important to know that as soon as you reach for that distributed system, this is the sort of problem we're trying to solve. And here are the trade-offs where you don't apply, for example, Spark to everything. You don't apply this or there's a lot of trade-offs there.
Right. So that's why some guy from Snowflake, they did 1 trillion rows. And yes, then it makes sense, right? Because I suppose I cannot process 1 trillion rows. Well, I guess I could process on that server, but it would just take a longer time. Whereas if I can scale it out in a Snowflake cluster, I don't know how many compute nodes they would use. I guess it could be, I mean, that problem is ideally parallelizable, right? You could run it on 1,000 cores if you wanted to. So then, of course, that's where this scale out approach makes tons of sense.
Well, maybe that's a good segue into the next question. Is there going to be another billion rows competition? Maybe it's 1 trillion rows. Maybe it's 10 trillion rows.
Yeah. So, I mean, I don't think I would do another 1 billion row challenge or trillion row challenge or whatever. I feel this problem is kind of solved, right? So I think it would be rather boring to just do that again. But yeah, so people ask, hey, do you do it again? What will be your challenge next year? I'm planning to take a week off next January so I can focus full time on the challenge back then. Oh, okay, people, let's hold on a second. I'm not even sure whether I would want to do it. But yeah, I don't know. I mean, I could see it. I think it goes back a little bit to what we discussed in the beginning. So this problem was so interesting for many people because it's easy to explain and it still opens up many angles of exploration and opportunity. So I think you would have to find another problem which is like that, and I think that's actually a tricky thing to find something like that which is approachable, which still has lots of potential, because you could easily come up with something which, where people can go off and work on it for like forever, but it would be hard to explain, and it would have like a larger, higher barrier to entrance. It might not be that attractive to many people. So that's the one thing, finding a suitable problem, but I think you could find something. The other thing is, as I mentioned, I mean, it was like really lots of work. So if I were to do it again, I definitely, I could see it if there was a team. And actually, I should also mention there was people who helped with running it also this time. So this was really great to see people from the community help me with setting up the new server. They helped building out this TCK, this test suite, because frankly speaking, I just wasn't super careful about like all the corner cases and like, I don't know, how many different station names could there be, all this kind of stuff. So people actually helped to clarify all that, and they pushed for clarifying that. And then they built a test suite, which then each entry had to pass to be like a valid entry. So, people helped with that. People helped with building all this evaluation infrastructure. So, there was one person who is a shell script wizard and did an amazing job of implementing all this tooling, which then would like regenerate the leaderboard, all this kind of stuff. And so this kind of happened this time. And I think if it was planned a bit more like next time, and there was like an entire team coming together, also if the evaluation was automated. So, I mean, this time, whenever there was a new entry, I went to my server. I was on my server. I pulled the entry, I ran the benchmark, I waited for it to complete, I would update the leaderboard. It was just like super tedious. Whereas like next time, if it was like all automated, maybe it could be a GitHub action runner, which takes some exclusive time on this machine, to run the entry there. So it's not that intense, time consuming activity. Then I could see it, but yeah, it also would require quite a bit more preparation. Absolutely.
There was a video I just happened to watch. It was about the Japanese Minnie Mouse competition. I don't know if you've ever heard of
Oh
it,
yeah, also
where
yeah,
they
that's
did the
super neat. Yeah.
maze solving. And what it
Yeah.
reminded me of this competition is maybe the competition isn't changing it from a billion rows, it's putting some constraints on there, where
Right.
they talked about some of the more ingenious things that people had to do to deal with the really really small ones. I found that
Right.
fascinating, where you
Yeah.
could strain it in some fashion where maybe you don't have
Right.
8 cores, maybe you have this much memory, maybe you
Right. Oh
constrain it
yeah.
arbitrarily.
Yeah. Actually, some people, now that you say it, some people use this epsilon GC, which essentially is a no-op garbage collector, just by means of being very efficient in reusing data, and just like essentially pre-allocating a defined amount of memory, and then they could churn through the entire 13 gigabytes within a heap size of 100 megabytes or something like that. So I felt also that's like super cool to see that you can do this kind of stuff. So you don't even need garbage collection for processing 13 gigabytes of file.
So what do you think is the overall message you wanted to convey with this project?
First, well, as I mentioned, Java is very much alive, and it's a competitive, attractive platform. Um, and I didn't touch on that specifically, but one of the things which people could also do is they could choose their JDK. So I use this tool, SDK man, which makes it very easy to allow to install different Java distributions, different versions, and so on. So this was one of the things which I hope people would explore, because different distributions have different garbage collectors, different preview APIs, different capabilities. So this was just interesting to explore that space. And I think this was one of the things, yes, bring across that, well, Java is like really, a highly competitive and up-to-date platform. And well, then of course, I hoped that people, would just use the opportunity and learn about this stuff, dig into details, maybe of things which they haven't done before. And based on the feedback I got, I think many people really enjoyed that experience.
Normally on this show, I'm interviewing people who started a business. So they've moved up into management in some fashion, or they're now a C-level, they're a CEO, they're a CTO,
Right.
but you're obviously a staff engineer. Do you think it's possible for a technical person to advance in their career without getting into management?
Oh yeah, I mean, definitely. I mean, I think it depends a lot on the kind of place where you are at, right? But I think nowadays with many tech companies, they have equally attractive technical career path where you can be a staff engineer, a distinguished engineer, um, where you have lots of responsibility in terms of providing guidance to teams and providing architectural oversight and this kind of stuff on a technical level, but you don't have this people management responsibility, right? So I mean, definitely I would recommend everybody who is interested in that to look for those places because they definitely exist. And then yes, I think you can make a very attractive career. I mean, in terms of financial aspects, but also in terms of like what is it you want to do, and so I don't think you have to move to people management to make a career. I think those days are definitely over.
Well, good. Well, Gunnar, thank you so much for being here. I really appreciate it. I enjoyed this conversation. I hope you did too.
Absolutely, yes. No, thank you so much for having me. This was fun. I think it was the longest. How long did it take? Like 2 hours. I think one of the longest recordings I've done so far. This was great.
Thank you, Gunnar. Bye.
Absolutely.